Hi everybody, today's topic is parallel and perpendicular equations. This is Unit 1, Day 3. Our objective is I can identify if equations are parallel, perpendicular, or intersecting. Now if we're following our unit progression, we're now on our third day, parallel and perpendicular, and we'll get to midpoint, distance formula, and equation of circles in upcoming lessons. Our statement of inquiry today is this idea that parallel and perpendicular lines help create stability, structure, and art in the world around us. So I want to show you these three pictures here. Now, picture number 1, this leftmost picture, is a schematic of the Chadwick Building for the Department of Civil and Environmental Engineering at the University of London. The right-hand picture, this picture number 2, is a painting called The Reservoir by Pablo Picasso. Now, both of these images appear to have parallel, perpendicular, and intersecting lines. My question, though, is how do you prove that they are indeed parallel or perpendicular? How do you prove that they are intersecting? And what would happen to a building if they were not perfectly parallel? Now, let's take a look at the civil engineering picture first. A couple of our parallel lines that I can recognize here are these ones, right? And hopefully you can recognize that those represent the different floors, right? This is the basement, ground floor, mezzanine, first floor, mezzanine, second floor, right? Now, if those weren't parallel, what would happen? Eventually, the building floors would run into each other, right? They would be crooked. The ground wouldn't be exactly flat. And that has some problems for some of these maybe load-bearing structures to help make sure the building is stable. And if this happened continuously, you might end up with a problem kind of like that. It might have a slight lean, right? Which is honestly pretty dangerous. If we look at this piece of art right here, you can also see those lines right there being parallel, right? And you can see, look, they intersect right here. They intersect right here. Do we know if any of these are perfectly perpendicular? How could we figure out if they're perpendicular? And think about it from an art perspective, why would it matter, right? Do we want to make it appear as if it is parallel and perpendicular? And what kind of image and artistic purpose does that serve? All right. Now this last picture right here, picture number 3, you guys might recognize as the Leaning Tower of Pisa. Now, this building started construction in 1172, which is a very, very long time ago, and was built over the course of 200 years. And it began to tilt because of soft soil. So if you think about there's soil down here, it was really, really soft on the right-hand side. So the weight of the building started to make that side kind of sink into the soil, right? In 1990, it had a recorded tilt of 5.5 degrees. That means from the ground, if you would draw a perpendicular line going straight up and then follow where the building actually was leaning, that degree was 5.5 in 1990. After a decade of reconstruction, they fixed it so the tilt was only 4 degrees, right? And what they did was they dug out some of the soil underneath the left-hand side where it was raised in order to create a foundation that was closer to parallel, but not exactly parallel. They considered it important to keep some of the tilt because of the role it played in attracting tourism in Pisa. Since so many people came to Pisa to see the Leaning Tower of Pisa, if they made it not lean anymore, it would kind of lose some of its appeal. But it took 10 years to fix, which is kind of crazy. Now, the first thing that we're going to be looking at today is what are parallel lines? Now, parallel lines are lines that always have the same distance apart and never touch. So if we look at this picture, the red line here and the blue line here, at any point, it is always that distance apart from each other. They go on forever and ever, and they will never touch. The most common way to indicate that lines are parallel is by drawing these kind of arrows in the middle of the line. That proves it is information to you that tells you those lines are parallel. Now, parallel lines have the same slope but different y-intercepts. And this is really important. We're going to be focusing especially on the same slope. All right, so if we were to follow like the rise and run here and then the rise and run here, you'll find that their slopes are identical, but their y-intercepts are a little bit different. I'm just going to clear this. It's a little bit easier to see. Our y-intercept right here and our y-intercept right here. We know they have the same slope, but their y-intercepts are different. If you think about the word parallel, you have these 3 L's, and all those L's are parallel to each other, so that's kind of a way that I remember. Parallel has those 3 L's, they never touch, so on and so forth. So if you look at these two equations, 2x plus 3, 2x minus 1, you'll recognize that 2 means that they have the same slope. The 3 and the negative 1 are your different y-intercepts, all right? If we talk about opposite, we're talking about a change in the sign, so going from positive to negative or negative to positive, right? 7 and negative 7 are opposites. A reciprocal fraction is when you flip the top and the bottom of the fraction, so that when you multiply those two values, you get 1. For example, 2 over 5 and 5 over 2 are reciprocal fractions, all right? Now, when we talk about perpendicular lines, they're lines that intersect at a 90-degree angle. And the way that we indicate, that using that geometric language that something is 90 degrees is to draw a little box. If you see that box, that is somebody telling you, we know for sure this is 90 degrees, all right? Now, perpendicular lines have opposite and reciprocal slopes. So we need to think about what is their slope, we need to change the sign, and we need to flip the fraction, all right? So right here we have 2x minus 5 and negative 1/2 x plus 7. If we have a number like the number 2, in order to make that a fraction, you can always put it over 1, all right? So if we start off with a slope of 2, if we change the sign, you'll have negative 2 over 1, and then if you flip the fraction, you get a negative 1/2, right? So here, if you have a slope that is 2, the perpendicular slope is negative 1/2. And you'll see this little symbol right here means perpendicular. Let's take a look at our first teacher example. It asks, which of the following equation is perpendicular to the equation 3x minus 8y equals 24? Now, because in order to determine if something is perpendicular or parallel, we look at their slopes. We need to convert this from standard form that it's in right now into another form that has slope. The easiest form to convert it into is slope-intercept form. So we're going to take 3x minus 8y equals 24. Now here our y is negative, so I'm actually going to move that to the other side, so I end up with a positive y. I'm going to add 8y, add 8y. Our 8y's go away because it goes to 0. Our 3x comes down, and we get 8y plus 24. From here, I'm going to subtract 24, so I can get y by itself. We're isolating the y. 24's go away. 3x minus 24 equals 8y. And again, I want to isolate y. I know they're being multiplied. The opposite of multiplication is division. So I'm going to divide everything by 8. 8 divided by 8 goes to 1. So I can cancel that out. And I get y equals 3 over 8x minus 4, which is, oops, not 4, my bad, minus 3. And you get 3 when you do 24 divided by 8. Now, once we have it in slope-intercept form, we can recognize that the slope here is 3 over 8. Because we want what is perpendicular, we know that we're looking for the opposite and reciprocal slopes. Opposite meaning I'm going to change the sign, reciprocal meaning I'm going to flip the fraction. So my perpendicular here is, it's going to go from a positive to a negative, and then my 8 will be the numerator and 3 will be the denominator. So now I'm going to look at my answer choices A, B, C, and D and find the equation that has a negative 8 over 3 as the slope, which I see in B. So I know that the perpendicular equation to the one that was given to me is B. Take these steps and try your student example number 1. All right, now let's move on to teacher example number 2. We're looking at, is the segment BA perpendicular to segment EB? In order to do this, we're going to need to find the coordinate points of A, B, and E. And you'll find here we know that A is 2, 7. B is at -4, 6. And E is 0, 2. All right. Again, we're looking at perpendicular, which is telling us opposite and reciprocal. So we need to find the slope of BA. We need to find the slope of EB, and then determine if those two slopes are opposite and reciprocal. Let's start by finding BA. So I'm going to label my x1, y1, x2, y2. And I know in order to find slope, we're doing y2 minus y1, x2 minus x1. And we plug in these numbers. (6 minus 7 over -4 minus 2, -1 over -6, which we can simplify to a positive 1/6. And we can double check that by doing, we're going up 1, and then 1, 2, 3, 4, 5, 6. So if we're doing rise over run, we know that 1/6 is correct. Now we have to find a slope of EB. Here, I'm going to just label this one as our x1, y1, and then keep our point B as x2, y2. You could flip them and then you'd get the same answer. So here we're doing 2 minus 6 over 0 minus, oops. Sorry about that, let me fix it. Doing y2 first, so we're going to do 6 minus 2 over -4 minus 0. And you end up with 4 over -4, which we simplify to -1. Right? And we said that if we had a whole number like that, we can put it over 1 to get a fraction. So we're comparing the numbers 1/6 and -1 over 1. They are indeed opposites in that one is positive and one is negative, but they don't have the reciprocal part, right? 1/6 would then become 6 over 1, which is not what we have. So is BA perpendicular to EB? No, it is not. What you'll find, though, is they do intersect. So if we were to draw out those lines, BA, EB, we know they intersect at point B. Intersect is another word for cross. So try this on your own. Is JC parallel to BK? And remember, what does parallel mean? What do you know about parallel? Oh, they have the same slope. Okay, let's take a look at teacher example number 3. What is the equation that is parallel to the equation 4x minus 7y equals 8 and crosses through the point 14, 2? So again, since we're talking about parallel, we need to find what the slope is. If it's given to us in standard form, then we need to convert. 4x minus 7y equals 8. And do the same thing where I add 7y. 4x equals 7y plus 8. I want to get the y by itself, so I'm going to subtract 8, inverse operations. 4x minus 8 equals 7y. I need to find what is the inverse of multiplication. Divide by 7, all the way through. Y equals 4/7 x minus 8 over 7. Now I have an equation that's in slope-intercept form. Since we want something that is parallel, we know that the slope is going to be 4/7. We have a point here, 14, 2, which we can use for x1, y1. So we can use our point slope form, because we have a slope and we have a point, to find the equation. As a reminder, point slope form is our y minus y1 equals mx minus x1. All right, so here y minus 2 equals 4/7 x minus 14. And that's your equation. We know that it's parallel and it goes through that point. So try the student example on your own. All right, and now this is going to be our last teacher example. It's very similar to our previous question, but instead of those being parallel, we're looking for a line that's perpendicular. So what is the equation that is perpendicular to the equation 5x plus 6y equals 24, and cross this through the point -10, 3. So the steps are almost identical. We start with our standard form, 5x plus 6y equals 24. And we know that we need to convert it because the form that it gives us, standard form, doesn't tell us anything about the slope. And we need to know about the slope in order to determine something that is perpendicular. Here, my 6y is already positive, so I'm actually going to start by moving my 5x. All right, they're being added, so I'm going to do the inverse, which is to subtract. The 5x's go away because it goes to 0. I bring down my 6y. I have -5x plus 24. Now my 6 and my y are being multiplied, so the inverse of multiplication is division, and I'm going to divide all the way across. And then I'm left with y equals -5/6x plus 4. Now here I know that my slope is -5/6. But since we're doing perpendicular, I know that we need the opposite and reciprocal slope. So my perpendicular slope is going to be, well, opposite means this negative is going to turn into a positive, and then reciprocal, I'm going to flip my numerator and my denominator, which means I'll have 6 on top and 5 on bottom. So my new slope, my perpendicular slope, is 6/5. Now I also know that I want it to go through the point -10, 3, x1, y1. Then we can use that same form as before, our point slope form, and plug in our given values. So y minus 3 equals 6/5 x minus -10. And we know that this minus and -10 we can simplify to a plus. And that's our equation that is perpendicular to our first given equation. Take a little bit of time and try your student example number 4. Now, same as always, for your summary, I want you to think back and what are the new pieces of information? What are the main points that you need to remember? It should be 3 to 5 sentences. And I really want us to think about how does this connect to our initial statement of inquiry? And make sure we're using our proper academic vocabulary. For example, if we're talking about perpendicular lines, you should have somewhere that perpendicular slopes are opposite and reciprocal. Those are using the proper vocabulary that we learned this class. Thanks so much, you guys.